Okay, let's continue. We'll study sets. So we can ask, can we study collections of objects? Can we study the general properties of collections of objects? So a set is a collection of objects. So we can ask, what is a collection then? We are defining set using the word collection, but collection of objects. But what is a collection of objects? What is a collection? So this is an informal description. This is not a definition of sets. So the goal is to study collections of objects. A set is we call a collection of objects as a set. The objects of a set are called its elements. So a set is a collection of objects and the objects of a set are called its elements. So we can ask, can we have a notation? It's natural to ask this. Can we have a notation for this statements of this form? X is an element of set A. So we will have a notation. This symbol X and this symbol and A means X is an element of set A. So we read this as X is in A. So we read this X and this symbol and A as X is in A. So X is in A means X is an element of set A. Okay, so we will look at some examples. The set of positive even integers less than 10. This is, so the positive even integers less than 10 are 2, 4, 6 and 8. So this is the set of, we write sets using curly braces. So whatever is within the curly braces, they are the elements of the set. Here, just to show the notation, for example, 4 is in this set 2, 4, 6, 8. So 4 is an element of this set. So the set of positive even integers less than 10 is 2, 4, 6, 8 and 4 is in this set. Another example. The set of integers is written as Z. Here, for example, -1 is in Z. -1 is in the set of all integers. So the set of all rationals, the set of rationals is written as Q. So here, for example, -2/3 is in Q. So this is all just notation. So another example. The set of reals is written as R. Here, for example, square root of 2 is an element of R. Square root of 2 is a real number. Okay. Another example. The set of lowercase vowels is A E I O U. Here, for example, E is an element of this set, A E I O U. So another example, we can also have a set of sets. So consider the set of sets. So here, this set 1 comma 2 is itself an element of this set of sets. Right? So this is also a set. Now another example, the set of reals greater than 1, the set of all reals which are greater than 1. So that set is, you can write it as set of all t such that t is a real number, t is in R and t is greater than 1. The set of all reals greater than 1 is written like this. The set of all t such that t is in R and t is greater than 1. Here, for example, 2 is an element of this set. 2 is a real number which is greater than 1. Okay, so this is another notation to specify sets. So generally, this is the notation. Let S be a set the collection of all elements of S which satisfy a property P is written as this: the set of all X such that X is an element of S and X satisfies P. So the above notation is an example. The set of all reals, the set of all elements of R such that that element is greater than 1. The set of all t such that t is in R and t is greater than 1. That this is written like this as above. In general, if S is a set, the collection of all elements of S which satisfy a property P is written as this: the set of all X such that X is in S and X satisfies P. So this is a natural notation. So another example, this is an important example. We can also have the empty set. We can also have empty sets. So an empty set, for example, the set given by this expression, set of all reals with square to -1. This is the empty set. So sometimes when we describe sets using this notation, the set of all X in S such that X satisfies P, it may turn out that there is no element which satisfies that property. So in those situations, we naturally get empty sets. So for example, this is an empty set. This is the empty set. So we denote the empty set by just braces, and the empty set is also written as so the empty set is also denoted by this symbol. Okay, and yeah, so finally, just one comment. Note that a set is defined by the elements it contains. So order and repeat mentions do not matter. So for example, this collection of objects, so this sets 2, 4, 6, 8, and this set, let's say 8, 4, 2, 6. These sets are equal. Both sets are defined by the elements they contain. They contain the same elements, so order doesn't matter. Even repeat mentions don't matter. For example, sets 2, 4, 6, 8, and say 2, 2, 4, 4, 6, 6, 6, 8. So both these sets are equal. They both contain the same elements, which are 2, 4, 6, and 8. So order and repeat mentions do not matter. So, right. So that's all for this part. See you in the next part.